All right, hello, hello. We are going to talk about section 1.2 here. There's the link to the textbook there that goes with it. And here we're going to talk about the domain and the range, which we kind of mentioned a little bit last time. And we're going to look at that in some more detail here. So here you will notice we have a whole bunch of points. So we've got all these different coordinates of points, and you've dealt with points before, I'm sure. There you go. There's a bunch of coordinates. And, remember that every coordinate, every point is written as x comma y. So you have the x value first, followed by the y value. And we mentioned this in the last section, but here's basically what you need to know. The domain is basically all the possible x values. And so here they say, find the domain of this function. So what we're going to do, you see this squiggly bracket here, that's how you make a list. So what you would do is you would say D for domain, and then we'll put this kind of squiggly bracket thing here. What are all the different x values that we see? There's a -5, a 0, a 5, a 10, and a 15. That's it. So we're just going to make a list of all of those, and we're going to say, okay, here's your domain. It's -5, 0, 5, 10, 15. There you have it. That is the domain. So it's all the possible x values that you can have. If your function is just a list of individual points, you're just listing the individual x values. Okay. Given a function written in equation form, here's how you would find the domain. So first you have to identify the input values. Typically that's x. You could have a function in terms of other variables, but x is the most commonly used one. Identify any restrictions on the input and exclude those values from the domain, and then write your domain in interval form if possible. So let's say a brief word about any restrictions. And let's talk about what those restrictions could be. There are two possible hitches you could run into that would prevent you from putting a number into a formula. There are two big no-nos in algebra of things you cannot do. So let's talk about what those would be. So restrictions. Number one, you can't divide by 0. That is the first restriction. So if you have a situation and you're dividing by your input or something with the input in it, whatever that is, you cannot have any division by 0. The other big no-no is you can't take even roots of negative numbers. So for instance, I can square root 16, and that just equals the number 4. However, I cannot take the square root of -16 because that is not a thing. And if you get yourself a calculator and try to do square root -16, in a calculator, it will give you an error message because what you're trying to do is not possible. So you can't square root negative 16. Now I do mention even roots because you can have, you can do roots of higher powers. You could do, for instance, the fourth root of 16. And if you wanted to do the fourth root of 16, I'll show you how you could do that. So we talked earlier about doing the third root of 8. If you want to do a fourth root, the first thing you would do is type in the number 4. And then again, if you hit the math button, and just under where we did third root, you'll see there's the X root right underneath it. So that lets you do any root that you want. And you notice it rewrote on the screen there. It's now got 4 in the little radical symbol there. And if you do the fourth root of 16, it turns out that that's equal to the number 2. So the fourth root of 16 is 2. So that works. If you try to do the fourth root of negative 16, that will also give you an error message. So you can do any even root. The square root is like the index, they call it, is a 2. The index is just the power that it undoes. 2 to the 4th power is equal to 16, which means if you do the fourth root of 16, you will get 2. And doing an even powered root would give you, doing an even powered root only works for positive numbers. Now, fun fact, we saw this earlier. If you do the third root of 8, that is the number 2. It is also possible to do the third root of negative 8, which it turns out is equal to negative 2. So if you do an odd power, that is okay. You can do odd powers of any number you feel like. But if you're going to do an even powered root of negative numbers, that's not going to work. So let's look at this example here, shall we? They ask us to find the domain and they give us this function here. 5 minus x plus x to the third. Here's the thing to notice. The first no is dividing by 0. Well, guess what, my friends? I don't see any dividing there at all. So the first restriction is not going to be an issue. So number 1, there is no dividing at all. The second restriction is even powered roots. Well, guess what? I look at that formula, I don't see any roots either. Those are the only 2 things that could give me any problems. So if those are not an issue, that means that there's no restrictions. There's no restrictions. So I can use any number. Now, the mathy way to say that you can use any number, they say write it in interval form. So here's how we're going to write this in interval form. We're going to say D, and then we're going to give an interval. An interval, you're going to say it goes from negative infinity all the way to positive infinity. It looks an awful lot like a function, or no, I'm sorry. It looks an awful lot like the coordinates of a point, but what we're saying is the lowest value it can be, there's no limit. It can go negative infinity. It can go as low as it wants to. The highest possible value is on the right side, and it can go as high as it wants to infinity and beyond. There's no limit. You can put negative 10 billion in this formula. You can put 57,829 billion in this formula. Doesn't matter. Any number at all can go into that formula. There's no restrictions. And so the math way to say that, to get that idea across, it's written like this: negative infinity to positive infinity. So the idea is you can use any number. The thing you all need to know is like the appropriate way to write that. It's sort of like emojis, and people who are in the know what that means. That's what this means. It just means any number. I have run into issues where I used emojis not fully appreciating what they mean to people. And it was, shall we say, a bit cringe, as the young people like to say. There was a time where my wife, my wife was making eggplant parmesan for dinner. So I sent like an eggplant emoji, and my niece and nephew basically pointed out to me that I should not do that. So there, I was like, I like eggplant parmesan, and they're like saying you're excited that your wife is doing and then doing eggplants. Don't do that ever. So yeah, so that was. I'm not sure what that story had to do with anything, but there you go. So yeah, that's what this means. There you go. Let's see, where were we? All right. Given a function written in equation form that includes a fraction, find the domain. So identify the inputs, find any restrictions on the input. And we kind of sort of said this earlier, but here they're sort of formally introduced. So we got any restrictions. And they're saying you make the denominator equal to 0 and solve for x. And then if it has an even root, it needs to be greater than or equal to 0. So here's what you'll notice. For this function, we've got 2x minus 1. So what that means, we are dividing by 2x minus 1. And like I was saying earlier, you cannot divide by 0. That's the first restriction. You can't divide by 0. So essentially what that means is that 2x minus 1 cannot equal, which is equal with a slash through it, 0. It's sort of like a no smoking sign. You put a slash through it and say, none of that around here. No dividing by zeros around these parts. Now you'd solve this just like you'd solve an old-fashioned equation. So since you're subtracting 1, what are you going to do? Well, you're going to add 1. So there you go. 2x equals 1. Then you're going to divide by 2. And 1 divided by 2 is just the number a half. So essentially what this means is x can be any number except 1/2. In plain English, that's what that means. Now we need to talk about how do you write that as an interval. And here's what I'll do. I'll even draw this on a number line to maybe hopefully kind of sort of make it make sense. So 1/2 would be just like right here somewhere. We're going to have a hole right here. It cannot be 1/2. It can be anything above 1/2. So it could be, for instance, 1 or 3/4 or 10 or 15,000, whatever. It can be anything smaller than 1/2. It could be 0. It could be -20. It could be -10,000. It could even be 1/4, which is smaller than 1/2, in case you didn't know. So negative infinity is all the way to the left. Positive infinity is all the way to the right. And so if we're going to write this as an interval, here is how you would write that. You would say the following. You start from the left and go to the right. And you'd say you can be anything from negative infinity to 1/2. So you say negative infinity, comma, 1/2. That is the left side of that number line that I just drew. So you can be anything to the left of 1/2. That's what this means. Left of 1/2. And then what we're going to do is we're going to do a U, which means union. We're going to put this together with another interval, another chunk of stuff. And we're going to say, okay, we're going to start at 1/2 again. And then we're going to go all the way to the right, all the way to positive infinity. And then that is how you would write the interval notation. And so then this thing over here means everything right of 1/2 is what that means. And then that is the U symbol, which means union, which essentially means you're going to unite them and put them together in one big thing. Those two things together are the domain. Okay. Let us see what else we have here. So this is the same thing. So we did it once where we saw the division thing. So here we've got an even root. And so we're going to set the radicand greater than or equal to 0 and solve. Notice it says greater than or equal to. So essentially what we're going to do, what is inside here is 5 plus 2x. Since that is what's inside the root, what we need to do is say, okay, 5 plus 2x, that needs to be greater than, so you do a greater than symbol, which is like the little alligator mouth kind of thingy. It eats the thing that's bigger. So that's 5 plus 2x. It can also be equal to, which is, this is where you put the line under it. So that's greater than or equal to. It can be bigger than the number, or it's also allowed to equal the number. And so that has to be greater than or equal to 0. So with square roots, you can put in anything that's not negative. You can put in 0, you can put in a number that's positive. So what we want to do is we want to solve this for x. So we're going to subtract 5 right here. And we're going to say 2x is greater than or equal to -5. Since we're multiplying by 2, we're going to divide by 2. And then that's just going to give me x greater than or equal to -5/2. So now what we need to do is we're going to write this as an interval. So what does that look like as an interval? I personally think it's always helpful to kind of draw myself a picture so I can kind of see what I'm describing first. So -5/2, we'll just put that right here in the middle. There's like -5/2. It is allowed to equal -5/2. So I'm going to put a filled in circle right here. -5/2, also known as -2.5. That is one of the possible numbers you could put into this formula. And then they say it's greater, which basically means I can be any number that's bigger than that, which means it can be basically anything over here to the right. And again, if you go to the right forever, that is infinity. So basically what this means is it can be anything so it can be -5/2 or anything bigger. So it could be -1, it could be -0.5, it could be 0, it could be 5, it could be 10, it could be 30, it could be 10,000, whatever. Now, how do you write this as an interval? Now, here's something we haven't seen yet. Before, I was always using parentheses when writing an interval. So with an interval, you use parentheses for when you get close but never arrive at a value. So like last time, it was like +0.5. We could get really close to 1/2, but we couldn't actually equal 1/2. And then fun fact about infinity, you always use a parentheses with infinity and negative infinity because infinity is not like a legit number. You can never actually get there. You can't equal infinity. Now, in this situation, we're going to use square brackets when equal to a specific value. In this case, it can equal -5/2, and it can be anything bigger than that. So the way we would write this is we would say, okay, we're going to start with a square bracket, and we're going to start at -5/2. We can start exactly at -5/2. That's where we will start. That value included. And then we'll put a comma, and we can go forever to the right, going all the way to infinity. And then infinity or negative infinity always will get a parentheses no matter what, because they're never actually values you can reach. They're not a legit number. That is the domain. That is the interval that goes with that domain. Okay. We're about halfway through this section, and it's a little bit past 8 o'clock. So I'm going to stop there for now. We'll take a break, and then we'll start up again in about 15 minutes or so. So I'm going to start up again at 8:20, and then we will finish this section and then go on to section 3 after that and see how far we get. So I'm going to stop there, and let's take a 15-minute break.